Hello everyone. So now we will study why do we use MOSFET in saturation region only for amplification. Okay. So multiple times I have used in MOSFET biasing chapter or in most physics chapter that we will use MOSFET in saturation region for amplification. So now why that? Okay. So we will see that, but before that, to understand that point more precisely, we need to see this. So there is a question like there is a two-port network. We apply some input voltage to that Vs, okay, and that has some internal resistance Rs. So you need to find the Y parameter condition for which the voltage configuration of the whole configuration is maximum. So like this is the Y parameter you have. This is V1, I1, V2, I2 that you know, right? And we will have voltage source here, Vs and Rs. Okay. So this is Rs and this will be Vs. Okay. Then we will have a load here. That will be that load will be RL. Okay. So yeah. So for Y parameters, what we can write? No, for Y parameter, what we can write? The basic equations you must be knowing. I2 equals to Y11 V1 plus Y12 V2. Not I2, it should be I1. I1 should be equals to Y11 V1 plus Y12 V2 and I2 equals to Y21 V1 and Y22 V2. Okay, that you know. And now what you need to do, you need to maximize V naught by Vs, okay, or V2 by Vs, right? This is your task. You can maximize this V naught. I shouldn't draw it like this. V naught should look something like this. If I make the node potential 0, then I have to make this ground. Okay, so this is how it will look. So you need to maximize V0 by Vs and V2 by Vs. Okay, so for that, what we will do, we will make the internal structure of this one. Okay, we will make the equivalent circuit. So you need to know how the internal structure or equivalent circuit of Y parameter look like. This is how it looks like. Okay, V1 is equals to just put just put V1 here. So it would be I1 would be equals to V1 Y11 V1 plus Y12 V2, and this would be the port 2. This is port 1 and this is port 2. If you consider port 2, this is how it will look like. Okay, V2 equals to Y22 I2 plus Y21 V1. Now you need to maximize V0 by Vs. Okay, maximize V0 by Vs. Now what you can see here is that this V1 is amplified by factor Y21, right? This is the V1. From Vs source we are getting some V1 across this resistance or this current source, you can say. Across this we are getting V1, okay, and this V1 is amplified into Y21 V1, and then this I2 current flows through the resistance and you get V2 equals to minus I2 RL. So if you get maximum V1, you will get maximum current here, and then you can get maximum value of I2, then you can get maximum voltage. If V1 is the maximum, then this current source will be maximum, then this current will be the maximum. If the current is maximum, your voltage will be the maximum. So you need to have maximum V1. If you want to have maximum V1, what you should think? That the resistance seeing through this terminal should be infinity. If we have infinite impedance here, then there will be no current. So this Vs would be equals to V1. So what we can write? We need to have maximum V1. right? We need to have maximum V1. So if y11 goes to 0 and y12 goes to 0, then R equivalent is infinity. If y11 is 0, this will be infinite impedance. If y12 is 0, the current source is 0. If the current source is 0, that means infinite impedance. If voltage source is 0, that means short circuited. If current source is 0, that means open circuited. So this complete circuit will be, this complete configuration will be open circuited. So your Vs would be, V1 would be equals to Vs. So this is the first condition here. Okay, y11 and y12. This is the first condition. Y11 and y12 should be equals to 0. Now talking about this. Okay, now talking about port 2. Talking about port 2. So port 2, this is the equation I2 equals to y21 v1 plus y22 v2. Here, what is v2? v2 is minus I2 RL, right? v2 is minus I2 into RL, right? So put minus I2 into RL here. So it would be I2 equals to y21 v1 minus y22 RL I2, right? So your I2 would become 1 plus y22 R2 equals to y21 v1. So your I2 by v1, I2 by v1, that would become y21, not R2, it is RL, y21 upon 1 plus y22 RL. Okay, now if y22 is equals to 0 and y21 is maximum, then I2 by v1 would be maximum, right? Now what is v0 by vs? You need to maximize v0 by vs. What is v0? That is minus I2 into RL. And now we are putting y22 equals to 0. Is y22 equals to 0. That means it would be infinity. So the complete current I2 would be equals to y21 v1. Right? v0 equals to minus y21 v1 into RL. And now what is v1? This is v1, not vl. What is v1? v1 is equals to vs only. So v0 by vs would become minus y21 RL. So here you can also see you need to have a maximum value of y21 so that your gain is maximum, right? So basically, if you make this resistance look infinity, this current source look 0, and this resistance look infinity, then this Vs would be completely amplified into this y21 Vs, and the whole current will be flowing through this resistance. No current will go through this resistance. We don't want any current to go to any other resistance. So this y1 upon y22 would be 1 upon y22 would be infinity. So for that you need to make y22 equals to 0. So if you make y22 equals to 0, no current would be flowing through this resistance and whole current will be flowing through the resistance. So we will get maximum value of v0 by vs. And also here you can see if you need to maximize I2, you need to maximize I2, you need to make this one as 0 and this one as the maximum. So what did you get? What is the final result we are getting? We are getting as your y11 equals to y12 equals to y21 should be equals to not y21 y22 or y21 y22 should be equals to 0 and your y21 should be equals to maximum. This is the condition for maximum gain. Now what was written? What was I1? I1 was y11 v1 plus y12 v2. I2 was y21 v1 plus y22 v2. Right? So what is y11? Y11 is delta I1 by delta V1 with V2 being constant. Right? If V2 is constant, just partially differentiate it. Del I1 by del V1. That would be Y11. What would be Y12? Y12 is delta I1 by delta V2 with V1 being constant. What is Y21? Y21 is delta V1 upon, sorry, delta I2 upon delta V1. This looks like a transconductance, right? Output current on input voltage. We will see that with V2 being constant. And what is Y22? Y22 is delta I2 by delta V2 with V1 being constant. So this and this should be 0 and this should be maximum. Okay. So this is the condition that we got for Y parameter. So this was the question asked. Okay. So we have solved this. Now we are considering a MOS circuit. Now consider this MOS. This is VGS. This is VDS. This is two-port network, right? A MOS is a two-port network. V1, I1, V2, I2. To simplify, here your VGS is V1, IG is I1, your VDS is V2, and your ID is I2. The best thing about MOS is that here I1 is 0, right? So y11 equals to y12, that is equals to, or we can write it in elaborate manner. So y11, what is y11? Delta I1 upon delta V1. Change in I1 current with respect to change in V1 voltage. Change in IC current, change in gate current with respect to the change in VGS voltage. There is no gate current, so there is no point of changing. So there is no point of current being changed. So it would be equals to 0. And similarly, what is y12? That is change in I1 current with respect to change in VDS voltage. But there is no current, so there is no point of this. Okay. So for triode and saturation, for both of the region, this is always 0. Right. Now consider next two factors. First, we will write the current equation for triode region. Mu n Cox W by L VGS minus VT into VDS minus VDS square by 2. And for saturation region, we are taking ideal condition as of now. Okay. Mu n Cox W by 12 VGS minus VT square. Okay. First, we will consider, let's consider y12, that is equals to del I2 by del V1 with V2 being constant, right? What is, did I write y12? No, y21. So let's consider y21. What is y21? Here we have written, what is y21? Del I2 by del V1 with respect to V2 being constant. That means this is del ID. What is I2? I2 is ID with respect to del VGS. Delta VGS with V2. What is V2? VDS. VDS being constant. So this is what we need to know. Okay. So for triode region, now this is equals to what? delta ID upon delta VGS. This is equals to what? GM, transconductance, right? So for triode region, what is the transconductance? Mu n COX W by L VDS, right? And here VDS is very less than, not equals to, VGS minus VT, right? Because we have seen the characteristics and I have told you as well. This is I2, sorry, this is ID versus VDS we were plotting, or ID versus VGS we can also plot. So you know that in triode region, in deep triode region, VDS is very less value. VDS is very small. If VDS is, we shouldn't write like this. We can write VDS very small, right? VDS value is very small. Because if VDS is at this side, then only you will have triode region, right? So VDS is very small. That implies what? GM is very small. So that shows that Y21 for triode region is very small, right? Now consider for saturation region. For saturation region, what is GM? Mu n COX W by L VGS minus VT. So that's a good value, right? How can you say that? What is ID versus VGS? ID versus VGS. Mu n COX W by 2L VGS minus VT square, right? Here ID and VGS have a square relation. Here ID and VGS have square relation, right? ID and VGS are having square relation. So del ID and del VGS would be large, right? Like if y equals to x, then dy by dx would be equals to 1 only. If y equals to x square, then dy by dx would be equals to 2x. Then if x varies, the dy by dx will keep on increasing. For x equals to 5, dy by dx will be 10. So if ID and VGS have square relation, the del ID upon del VGS would be large. Or what, or how you can see is that ID versus VGS curve we will see, and then we will see this is ID and VGS, right? Del ID upon del VGS is the matter of fact. So if you just consider any point, just consider a slope on this point. So right, so this is a larger slope, right? So just to see the slope is very large, right? So but here you cannot say that this point will be in saturation region only. That you cannot say, because here we can have triode region as well, right? But that's not a matter of fact. The matter of fact is the slope. So you can, here also you can see that ID and VGS have square relation. So because of that, del ID upon del VGS would be large. So for saturation region, Y12 is large. So basically, if the interviewer asks you the question, you have to reply within a minute. So what you will say? The change in output current with respect to the change in input voltage is larger in case of saturation region, and in case of triode region it is less. How it is larger? You will just write del ID upon del VGS, output current upon input voltage, change in output current upon change in input voltage, that is equals to the transconductance, that is mu n CoX W by L VGS minus VT in case of saturation region. In case of triode region you will write, in case of triode region you will say VDS is a very small value, that's why it is small. And in case of GM, if he asks you to explain why it is large, then you can say there is a square relation between ID and VGS. So if there is square relation, then del ID upon del VGS would be the. So if that is there, then we will have more gain in case of in case of saturation region. Or one more thing, we can talk about Y22 as well. Talking about Y22, I won't write the current equation again. Okay, I guess I can just copy. Yeah. So talking about Y22 in triode region, this is the current equation. In saturation region, this is the current equation. What would be Y22? Here I should write Y22 would be del I2 upon del V2, del I2, del ID upon del V2. What is delta VDS? Okay, so that we need to minimize. So in case of triode region, Y22, okay, or 1 upon RDS we can say. We have discussed about it, right? 1 upon RDS, that is equals to mu n COX W by L VGS minus VT. Okay, and in saturation region, what is Y22? 1 upon RDS, that is equals to 0, because delta ID upon delta VDS is very small here. No, sorry. Ideally, ID is not even depending on the VDS value. Ideally, the drain current doesn't even depend on the VDS value. So if it is not even depending, then your Y22 would be 0. But practically, we have seen the derivation, so no need to do the derive. Practically, because of channel length modulation, in saturation region, 1 upon RDS is equals to what? Mu n COX, oh, don't forget that, it is equals to simply 1 upon lambda ID, right? No, not true. 1 upon RDS is equals to lambda ID. RDS is equals to lambda 1 upon lambda ID. So it is equals to lambda ID. We have seen the derivation, right? In this derivation, we will just have 1 upon lambda VDS here. Then del ID upon del VDS you will do. You will get lambda into this current, lambda into ID. So ID set you can write. Okay. So this is the RDS value that you should remember, and also in most physics we have seen that. Okay. So no need to see the derivation here. I'm just telling that ideally it is 0 and Y22 is a quite high value, or what you can see here. There are more ways. Okay. We can see in more ways. ID versus VDS curve we will draw. Right. So what is ID versus VDS curve for MOSFET? Okay, this is what we are drawing practical. This is practical because here there is some slope in saturation region. This is saturation region and this is linear region. Okay, so practically here you can see this theta 1 you can say, and this is the theta 2 you can say. So theta 1 is greater than theta 2. That means your del ID by del VDS is greater than del ID by del VDS. That is in case of triode region, and this is in case of saturation region. So here Y22 of triode region is larger than Y22 of saturation region, and that is not desirable. So that's why we bias MOSFET in saturation region for amplification. So did you understand it? So if the interviewer asks you this question, so what will you reply? You will just reply two things. The change in output current with respect to the change in input current. Del talking about Y21. You don't need to say Y21 or Y22, nothing. The change in output current with respect to the change in input voltage is maximum in case of saturation region. And in case of triode region, the change in output current with respect to the change in input voltage is lesser than the saturation region. So this is one criteria, and the other criteria is also the output resistance. Look, this was called transconductance and this is called output resistance because we are talking about both output terminals. I2 is output, ID is output, or VDS is output. So the output resistance. So what you can say, this Y22, the slope is larger on this side and lower in this side. Yeah. So what you can say, this is Y22. If Y22 of triode region is larger, then that means RDS of triode region is lower than RDS of saturation region. That means the output resistance in saturation region is higher, right? If del ID upon del VDS is low, that means then delta VDS upon delta ID is higher. So the output resistance of saturation region is higher, so that there is maximum current in load resistance. If there is less current in the output resistance, then the maximum current will go in load resistance, right? You can see in this diagram. If there is least current in this resistance, then only the maximum current will go in this resistance, right? So if there is least current in the output resistance, then more current will go in load resistance. So if you want least resistance, you will want resistance to be higher. If you want least current, then you want resistance to be the higher one. So in case of saturation region, we see that the output resistance is higher than the triode region. That's why we bias MOSFET in saturation region for amplification. So this is the complete explanation. So there can be one more region. Okay, there can be one more mathematical analysis there. There is one more mathematical analysis. You can see that as well. That I have uploaded in YouTube. I will upload it here as well. Okay, after this video, I will upload that video as well. Okay, so one more region is there. That video is in Hindi. Those who can understand Hindi, for them it is fine. But those who can't, just need not to worry. Just read on the slides. Whatever I have written on the slides in that video, whatever I have written on the slide, by reading that only you will understand everything. The main aspect I have cleared here only. So just you need to read on the slide and everything you will understand. Okay, so that will be clear to you. Okay, thank you.